let's look at these examples then. So we're just going to now play around with a few algebraic expressions and try using these skills on them: factorizing, expanding, simplifying. And then I'll point you at some exercises in the text. So here is a problem where you're asked to expand out these two and then try and simplify by looking for like terms. So I'll multiply everything in this bracket by everything in that bracket. So I'm going to have 1, 2, 3, 4 terms, and then I'm going to try and simplify them. So the first one, a times a squared. A times a number multiplied by itself, that's what squared means. So not 2a. Okay, not 2a. That means the number 2 times by the number a. So a times a squared, not 2a. A times 2b, 2ab, using the convention, but I could have written ab2 or a2b. They're all the same thing, but numbers first, letters in alphabetical order. And then I go to b times a, which is ab, using the convention. And then 2 times b, 2b squared. If you got that, well done. If you didn't, have a look at it. Make sure you understand why it's that. Now I look at this. Are there any other terms involving a squared and only a squared? No. It's got to be exactly a squared. So the fact that that's an a doesn't help. Any other terms involving b squared? No. Any other terms involving ab? Yes. Okay, I've got 2 lots of AB plus another 1 lot of AB is 3 lots of AB. So I can simplify this to a squared plus 3ab plus 2b squared. And that's about as far as I can go with this example to simplify it. Factorize this. So again, for the purpose of this video, if I just paused it here, you could pause it here and then have a go at it, but let's look at it now. What I'm looking at is numbers in here that are the same, terms that are numbers inside these terms that are the same. Remember, q and n are numbers, so q appears in that term and that term, so I could take it outside a bracket. There are no n's in here, so I can't remove any n's. So I could say that's the same as q into, and then I ask myself, well, what's left? So 2q squared means this, look, 2q times q. So what have I got to multiply q by to get back to this? Surely 2q. So 2q is what I'm left with inside. To check, what's 2q times 2 times q rather, 2q squared. So I get back to what I started off with. What have I got to times q by to get this term? Well, there's the q, so I've got to times by 8n to get back to 8qn. So 8n. That would now be factorized. I could look at the numbers themselves and say, well, actually 2 goes into 8 and 2 goes into 2, so I could just take a 2 outside. What am I left with inside the bracket? And I could take 2q outside, the 2 and the q together. What would I be left with? If you're looking at this video, just pause it, try and fill in those brackets, and I'll pause it now. So this first one, if I take the 2 outside, what have I got to times the 2 by to get back to this q squared? What have I got to times the 2 by to get back to 8qn? 4, because 4 times 2 is 8, qn. So I'll end up with that. If you are factorising, always multiply back out and check you get back to that again. Does 4qn times 2 give that? Yes. And then finally, if I take 2q out, what have I got to times 2q by to get 2q squared? Another q to get the q squared. And here, 4n to get back to 8qn. So, that's the sort of thing you have to do, and there are some examples. Here's another one. Now I want to look at one or two problems from the text and then show you at an exercise where you can practice some for yourself. Subtract this from this. I don't like the way this is written in text, which is why I've picked it. Subtract this expression from this expression. To me, that means this. X minus 2y plus 5z minus 2x plus 3y minus 4z. Look at that. You see that that's what that's saying in words. Don't do it the wrong way around. I'm subtracting this expression from this one. So I'm subtracting the first one from the second one, effectively. Use brackets because that whole expression here is going to be taken away from that whole expression. So that would be my start point. Now, if we look at this, this is a problem, this minus sign. This means on its own, if I had this on its own, by the way, cross your z's because they look like 2's otherwise. If I had this expression on its own, what this means is this, and it's worth looking at. So let's just focus on this for a second. If somebody said to me, expand this, I can actually do it. What that means is, what's outside the bracket? Because I've got to multiply every term inside the bracket by that. Well, what's outside the bracket is this is minus, and what's missing is a 1. So I'm multiplying every term in here by minus 1. So that would give me minus 1 times 2x is minus 2x. Minus 1 times 3y is minus 3y. Minus 1 times minus times a minus gives plus 4z. So effectively, if you look at it, if there's a minus sign outside the bracket, it effectively changes the sign of all the terms inside the bracket. And I've got to bear that in mind when I look at this. So let's expand out these brackets. Well, the first one, that's as though it's just a 1 outside the bracket. So that's x minus 2y plus 5z. So I don't really need the bracket in that case. But here, this has got to be minus 2x minus 3y plus 4z. So this is a bit tricky because of this negative sign here. Yeah, thank you for spotting that. Plus 5z, yeah. So, another way to think about this is I'm subtracting all of these terms. In other words, I'm subtracting 2x, I'm subtracting 3y, and I'm subtracting minus 4z. In other words, I'm adding 4z. So that's the way to think about it. Now collect like terms. 1 lot of x minus 2 lots of x is minus x. So this is equivalent to minus x minus 2y minus another 3y is minus 5y. And finally, 5z plus another 4z is 9z.
So how come at the beginning you got what
So that would be simplified. All of this would simplify down to this. All of this would simplify down to this. I'll just say one thing at the end. I wouldn't start off an expression with a negative number because it's very easy to miss this minus sign. So if there's any positives, I'd probably start off with them. So finally, I'd probably write 9z minus 5y minus x, just to make sure that I don't miss off that negative sign at the start, but that's not critical. Here's another one. Simplify this, 2p divided by 8p cubed. 2p divided by 8p cubed is an expression that we often need to simplify. Now we've started to talk in terms of fractions. Remember, this is a number. We don't know what that number is over another number, so this is a fraction, one number over another, or a ratio. We can think of it as a ratio. I don't know what Q is, I don't know what P is, but I do know that whatever P is, it's the same at the top and at the bottom. So if I have any fraction, for example, 6 over 8, I can think of 6 over 8 as 2 times 3 over 2 times 4. If I think of it like that, that means if there's a 2 at the top and a 2 at the bottom, I can cancel them out. I can divide top and bottom by a number. In fractions, if you think back to school, divide 6 by 2, divide 2 by 2, divide top and bottom by 2, and I'm left with 3 over 4. The fraction 6 over 8 simplifies down to 3 over 4, because 2 is common to both. If the number is the same top and bottom, 2 in this example, I can cancel them out effectively by dividing top and bottom by that number. Nothing different in algebra. If P is top and bottom, it's a number, P, it's the same number, so I can cancel those out. So if you've got a number, a letter, a symbol which represents a number top and bottom, they can be cancelled. So this becomes 2 over 8q, because the p's cancel. But also, 2's goes into both of these numbers on top and bottom here. So I can actually say, how many times does 2 go into 2 once? How many times does 2 go into 8? 4. So I can replace the 2 with a 1 and the 8 with a 4. So I finally end up with 1 over 4q. Note, dividing that by 2 does not leave 0. It doesn't cancel it, it leaves 1. So don't make that mistake, okay? 1 over 4q. So all that cancels down to this by dividing numbers into top and bottom. What if I had 2p squared over 8pq? Now I think to myself, well, that's like 2pp over 8pq. I wouldn't necessarily write that, but that's what I'd think. So now I can cancel p's, top and bottom. So I can do that effectively. So I'm left with just 1p on the top. So when I'm doing this sort of cancellation, I would cancel that p with one of these on top. So I'd get rid of the squared symbol and just leave the p on the top. That's probably what I'd do, but I'd be thinking about this as I did it. So this would cancel down to, again, 1 times p is p over 4q. Just check you see that that cancels down to that later when you're looking at this. Here's another one. Okay, let's let's look at this for a second. These are all multiplied together. There's no multiplication symbol between the a cubed and the b squared, but it's implied that it's multiplied. So effectively, I'm multiplying all these together. Remember back to the drill at the beginning, if the base number is the same, a, I can multiply a cubed by a, because that base number is the same, then that's the same as a to the power 4. Because, again, it's implied if there's no power in front of, and by the a, it's a 1. So that actually means a to the power 1. 1 lot of a multiplied by 3 lots of a is surely 4 lots of a to the power 4. So I can simplify a cubed times a to a to the power 4. Similarly, I can multiply b squared by b cubed. I can replace that by b to the power 5. And c times c5 to the power 5 is c to the power 6. So all this simplifies down to a to the power 4, b to the power 5, c to the power 6. Using what we'll see is the first law of indices. When the numbers that multiplying together have the same base, a, b or c, I can add the powers. And that works if the numbers are fractions or if they're negative numbers. And so that's where it starts to get a little bit more complex, and then when you have to think about the exercises during there. So I'm just going to point you at this chapter 5 is the key one, on all the basic rules of algebra. And there's lots of exercises in there, and when we go through the workshop and you're at home and you want to practice your basic algebra just to get your skills up to speed, focus on that chapter. If you're feeling comfortable with these basic rules, look at the further algebra chapter, chapter 8. Not something we'll be focusing on particularly in this unit, but definitely next year. So you can start building up your skills in readiness if you're feeling happy. So don't rest on your laurels.